Hi folks, Chris McClure here. Now we are going to move toward talking about describing your data set by computing some measures. And in particular, we're going to be looking at measures of center and variation and of relative standing together with some box plots later on in this course. Now, looking back, we've talked about going about and getting your data set by taking a sample from the population. We also talked about some terminology and some examples of the terminology that we've explored is the sample statistic and how it's used to estimate a population parameter. We've looked at some different sampling methods, including the simple random sample as compared to simply a random sample. We've taken a look at stratified samples, cluster samples, convenient sampling, etc. Some are better than others, some are more appropriate than others. And then in chapter 2, we've taken a look at taking your data set and start organizing it by creating a frequency distribution and then converting that frequency distribution into some sort of chart, like, for example, a histogram. And from that chart, we should be able to discern what is the center variation. In other words, what is the distribution of that data set? And when we later on in the course start talking about inferential statistics, we'll be looking at making the connection between the shape of the distribution of our data set and compared to potentially the distribution of the population itself. We would expect that if we have a good sample, a sample that is representative of the population, that distribution of the sample should be similar to the distribution of the population that it came from. All right. Now, here in chapter 3, we're going to be looking at descriptive statistics for your data set. We're looking at describing your data set and using some of these key measures, which we're calling statistics, as a way of describing the distribution. Later on, we'll be talking about doing inferential statistics, meaning extending our impressions of the data set to make conclusions of the population that data set came from. Okay, so here in section 3.2, our first sample statistic is going to be some measure of center. We'll be taking a look at the mean, median, not so much the mode, but you know what the mode is as well. And I think that you have, probably computed these in a previous course, so we're not going to spend a whole lot of time with this. But we'll also take a look at interpreting these values a little bit, okay? So some measure of center is what we're talking about here when we compute either the mean or the median here. Now, when we mean the mean, when we discuss the mean of a data set, we typically mean the arithmetic mean. There are many different ways of computing the mean. There are, for example, the geometric mean, which involves, taking the nth root of, the sum of the nth powers of the individual data points and stuff. So that's not what we mean here. All we mean by the arithmetic mean, and I don't mean to be making a pun here, but it's just simply adding up the numbers in your data set and dividing by the number of numbers. That's another way of saying the arithmetic average. Now, a little bit of symbology here, notation. When you see this sigma, this is a Greek letter sigma here, that means the sum of a bunch of numbers. We usually use variable x to represent the values in your data set. So when you see sigma x, that means the sum of all the data values in your data set. Now, we usually use the lowercase letter n to represent the number of data values. In other words, the sample size. Little n is the sample size, the number of numbers in your data set. Capital N would represent the number of data values in your population if you really did know the number of individuals in your population. We typically don't know, so when we reference capital N, it's more theoretical discussion. Now, look, I happen to think that one of the hardest part about learning mathematics is learning the language, learning the notation. Now, when we say x bar here, we have this x over, or with a little bar, or a little line segment over the top. What we really mean is the sum of all the data values over the sample size. Sigma x over n. That means you're going to add up all the numbers in your data set and divide by the number of numbers. This is going to be your sample mean. It's the average, the arithmetic average of all the numbers in your data set, x bar. We use x bar as a sample statistic to estimate the true population mean. Population mean is given by the Greek letter mu. Now, x bar is what estimates mu. Right? It is the statistic that estimates mu. Now, if you happen to know all measurements of the individuals in the entire population, then you could very well get mu by adding up all those measurements of the individuals in your population and dividing by the number of individuals in your population. We typically don't know mu because we typically don't even know how many individuals that we have in the population. If we did, we would have done a census. We typically don't have the resources to do a census, so we take a sample and we compute the sample mean instead. Now, the sample mean has its advantages and disadvantages, pros and cons. It's fairly simple to calculate. Sample means drawn from the same population tend to vary less than other measures of center. So meaning, if we were to do this experiment many, many times, meaning we take a sample of size 100, or choose your sample size, but we not just do it once, but we do it multiple times, and then take a look at the distribution of those means, you would see that there's relatively little variation in those, that set of sample means. Not only that, it's important to realize that the sample mean itself takes every data value into account. So we would certainly expect that the sample mean gives us a very good measure of central tendency. But there is one key disadvantage of the sample mean as a measure of central tendency, is that it's sensitive to every data value. In particular, if you have an outlier, then your sample mean will be drawn out toward that sample or toward that outlier. So, for example, if you have a business, and every individual in your business is paid, say, $25,000 per year, but you as the owner make $1 million per year, and then you were to calculate the average salary of everybody in the business, including yourself, that average would actually be over 25,000 because of your high salary compared to everybody else's. And it wouldn't be 25,000, which would be more representative of the individuals in your population. Okay. Here's an example of the computation of the mean. Now let's take a look here. If you were to look at table 3-1 in the textbook, we would have counts of chocolate chips and different cookies. Find the mean of the first 5 counts for Chips Ahoy regular cookies. 22 chips, 22, 26, 24, 23. All you need to do, folks, in computing the sample mean is just to add up the numbers and divide by 5. Why? Well, because in order to compute the average of 5 numbers, you add up those 5 numbers and divide by 5. So you add up those 5 numbers, you get 117 divided by 5, and that works out to be approximately 23.4. Now, just understand that your level of precision in your answer should be 1 decimal place further beyond the level of precision in your data. Notice that all of these are integers in your data set here. So it's perfectly acceptable for your answer to be rounded to 1 decimal place. If your data values were expressed to 1 decimal place, then your mean would be expressed to 2 decimal place, and so forth. All right, the median is a different measure of central tendency. You probably remember this from grade school. All you need to do is just order or sort your list of numbers from smallest to largest or largest to smallest and pick that data value that's right in the middle, or take the average of the middle too. Now, instead of x bar, we use x tilde with a little squiggle over the top of x to indicate the median. It's easy to compute, and it is not affected by extreme values. It is resistant measure center. So you might have 1 or more outliers, extreme values. But your median is only affected by the number of individuals in your data set, really. So again, to find your median, you're going to sort your data list from smallest to largest. If you have an odd number of numbers, then your median is going to be your middle number. If you have an even number of numbers, then take the average of the middle too. So for example, if you have this set of numbers right here, you got 7 numbers. Just sort that list from smallest to largest like you see here, and then choose that number that's right in the middle, which in this case is the 4th number, 0.73. It's the 4th out of 7. So if you have n as your data set, then n plus 1 over 2, as in 7 plus 1 is 8, divided by 2 is 4. So the 4th individual is going to be your median. If you have an even number of numbers, like I said, sort it from smallest to largest, and then take the average of the middle too, which will be your 3rd and 4th numbers in this case. So you take 0.73 plus 1.1 divided by 2, and that works out to be 0.915. So it's not surprising that your median, the median of your data set, would be some number that's not in your data set in the case of an even number of numbers. The mode is simply that data value that appears the most. And this actually works for quantitative and qualitative data. You could have one mode, you could have two modes, in which case you'd have bimodal, multimodal if it's more than two, or you could have no modes if there's, well, no mode. In which case you would have no data value that's repeated. Mode is the only measure of central tendency that could be used with nominal data. So, focusing just on numbers, if you have this data set here, are there any numbers repeated? And the answer is yes, it's 1.1. And 1.1 is the data value that appears the most. What about the second data value, or the second data set here? And the answer is there's two modes, 27 and 55, because each value is repeated 3 times. And then for part C, there's no mode because there's no value that's repeated. There's yet another measure of central tendency, not used very much, but it might show up from time to time. It's called the mid-range. And it's, if you're to take the smallest number and the largest number in your data set and take the average of those two values, then that would be your mid-range. But it is very sensitive to extreme values because it only uses the two values in your data set of your maximum and minimum values. It is easy to compute, but it's different than the median, though. Now, again, I already mentioned this once regarding how do you express the value of your average. It's going to be one more decimal place than how your numbers are expressed in your data set. And also think about whether your results are reasonable. Again, you should expect that your measure of central tendency should be somewhere between the smallest and largest values in your data set. Okay? And also, is it appropriate for you to use mean or median if your numbers are actually qualitative data? For example, the ranking of these textbooks doesn't make sense to have an average ranking. Okay? And it doesn't make sense to have an average jersey number. Okay? Now, a little bit more advanced stuff here, but it's still based on what we've talked about. If you happen to have data that's already organized in a frequency distribution, then all you need to do is just simply take the frequency times the data value divided by the total of number of numbers, which would be the sum of the frequencies. For example, suppose that you've got the frequency distribution from the IQ scores in Chapter 2. Here's the frequency distribution here. For a total of 78 individuals, there were 2 individuals with IQs between 50 and 69, 33, 70 to 89, and so forth. Excuse me. So here's your frequencies. Now, F stands for the frequency. Now, suppose this is all that you have for your data set, and maybe you've lost the original data set. Now, you won't be able to compute the exact mean of the data set, but if this is all you've got for group data, then what you'll need to do is to get a representative value from each category. Well, when you have a range of values, then you're going to want to choose the midpoint. So the midpoint is going to be the average of the lower and the upper boundaries. Well, not necessarily the boundaries, but the lower value and the upper value. So 50 plus 69 divided by 2 is 59.5. 70 plus 89 over 2 is 79.5, and so forth. So here you've got your class midpoints, which is the number that's exactly midway between the lower and upper bounds for each class. And then you take your frequency times your class midpoint. 2 times 59.5 is 119, and so forth for all the other classes. So when you see f times x, that means the frequency times the value for each of the classes. And then you add up all of those f times x's. And that's what this symbology means here. And then notice that the total of the frequencies is 78, because there were 78 data values to start off with. So you're going to take the sum of those f times x's divided by the total number of data values, 78 in this case, and you get 92.3. Now, we're not saying that 92.3 is the average IQ score from the original data set is, but if this is all that you have for your group data, then this is how you compute it. So 92.3, though, should be fairly close to the average of all the IQ scores from the original data set. But it is the average or the mean of this group data. That's how you do it. So you take, frequency times the value for each class divided by the total number of individuals, which is the sum of the frequencies here. Okay? That's how you do it. Now, you could also compute a weighted mean. If different values have different weights. So you just take each value times its weight and add them all up, divided by the sum of the weights. So for example, we know that when we compute our GPA in school, is that an A counts as 4 points, a B counts as 3 points, C is 2 points, D is 1, F is 0. Now, suppose that for a semester that you earned an A for a 3-credit class, you earned an A for a 4-credit class, you got a B in a 3-credit class, a C in a 3-credit class, and an F in a 1-credit class. What is your GPA for that semester? Well, what you're going to do is you're going to compute the average of the letter grades with the weighting being done for the credit. So the credit of the class will be the weight of the grade. So what you're going to do is you're going to take the grade A for this class right here and weight it with the number of credits. So if she got an A, or you got an A for your 3-credit class, so you're going to multiply 4 times 3, and then you got an A for the 4-credit class, so you're going to take 4 times 4. And then you got a B for the 3-credit class, so you're going to take 3 times 3. And you're going to take the C, which is 2 times the 3 credits, and then plus a 1 times 0. So in other words, you take each class credit times the letter grade divided by the sum of the credits. Okay? So the number of credits times the point value for the grade earned. So there's your 3-credit class for times the 4 points for the letter A that you got for the class, and then there's your A in the 4-credit class, your B in your 3-credit class, and so forth, and then divided by the sum of the credits total, the total sum of the credits for your semester. So you earned 4 credits, or you were enrolled in 4 credits, 14 credits, I mean, and you had a total of 43 cumulative points, meaning if you were to take 3 times 4 plus 4 times 4 plus 3 times 3 plus 3 times 2 plus 1 times 0. In other words, you had 12 plus 16 plus 9 plus 6. That works out to be 43. Divided by 14 is about 3.07. Now, I realize that we had said that you should express your mean with one decimal place beyond what you'd earn, but it's standard practice to express GPAs out to 2 decimal places. Now, when you are working on MyStatLab, make sure that you pay attention to how the system wants your answer formatted. Okay. Now, before we leave, I wanted to show you something. I wanted to show you about MyStatLab. Actually, it's called StatCrunch. StatCrunch is the built-in statistical computational platform. Now, I've just got done inputting, or actually assigning some homework. I've assigned Chapter 2 review quiz, Chapter 2 review homework based on how you did on the Chapter 2 quiz, and then I've posted 3.2 homework. Now I'm going to open up Section 3.2 homework, and I'm going to preview it. And in particular, what I want to do is I'm going to fast forward, skip to one of these questions that's got some data to it. What they want you to do is to find the mean, median, and mode for this data set. Now, you could whip out your calculator and add up these 5 numbers and divide by 5 in order to calculate the mean. And you could sort these 5 numbers from smallest to largest and choose that number that's in between, or that's in the middle, to get your median. You can take the average of the smallest and your largest to get your mid-range. And of course, the mode would be that value that appears the most often. That's fine. You can do that. You could also have StatCrunch do some of this work for you. So how you do this is you hover over this little link right here, and then left click on it. This little menu pops open. Click on Open in StatCrunch. And StatCrunch software is going to launch with, actually there's 10 numbers, not just those 5. There's 10 numbers that appear. So you needed to do your work on these 10 numbers. They showed you the first couple, but you needed to actually do your computations with these 10 numbers. Okay. Now, you could have the software do some of this work for you by clicking on Stat in this case. And then you can go down here to Summary Statistics and then click on Columns. Now, we're only concerned about that first column, so we can just select var1, which is the name of this column. You could click and change that to any name that you want, but we'll just use var1 as the default. And then regarding which statistics we want it to compute, now we can scroll down here. We can compute the mode. That would be good. Let's go back up and see if we can find the median. Now, control click median. Let's go back up and click on, actually control click on mean. If you were to shift click, that would select everything in between, but control click, so you can select those 3 individuals. And then when you hit compute, you'll see this little box here that says that the mode of these numbers in the variable 1 column, meaning these 10 numbers, the mode is $54,188. Median is 52,609. Mean is 52,825.7. Okay? So that is the StatCrunch lesson for today. And I want you to get used to and comfortable using StatCrunch. In a future class, we'll talk about how to use your graphing calculator. Probably tomorrow's class, I'll show you how to use your TI-84 calculator to do these computations, okay? Well, that's it for today. I'll see you next time.